Now we are looking at variance of multiple inputs. When we have more than one type of material being added to the productions or using more than one class of labor, how do we calculate the variances of these materials and the labors? Let's take a case of making a cocktail drink, let's say pina colada. And for this drink, I need some pineapple juice, some pineapple slices, coconut cream, and some ice. When I'll mix them all together, it will give me a fresh glass of 300 milliliter pina colada. The recipe is to use 90 milliliters of juice, 30-gram weight of one slice of pineapple, 30 milliliter of coconut cream, and 150 grams of ice. In this recipe, some of the ingredients are expensive, others are cheap. For example, if in the recipe I will increase ice, final product of pina colada would be cheaper. If I will put lesser ice and put more of coconut cream or a pineapple juice, this will increase the cost of making 300 milliliters of pina colada. So here we have budgeted prices for individual ingredients, saying $0.05 per milliliters of pineapple juice, $2 per slice of pineapple, $0.1 per milliliter of coconut cream, and let's say $1 worth of an ice. This is our standard. So assume this was budgeted and now we have actual data of making pina colada. We have used here 100 milliliters of pineapple juice, a 3/4 of a pineapple slice, which is now 22 grams. Coconut cream is also used less, and we have used little more ice. And finally making 337 milliliters of one serving of pina colada. And the rates have been changed. Pineapple juice price have increased, rate of slice have decreased, coconut cream rate remains same, and there is also a difference in the cost of ice. And ultimately 337 milliliters of pina colada drink is costing us $12. Let's first calculate simple price variance, and if you remember, the formula for price variance was actual price minus standard price times actual quantity. Here we have to individually calculate price variance of each ingredient and then add them all together. For pineapple juice, the actual price is more than the standard price and actual quantity is 100 milliliters. By taking a difference of this, we get an unfavorable variance of $1.5. For pineapple slice, we do not have a per gram cost, so I will find a per gram cost for standard and actual. Taking a difference and multiplying it with 22 grams, which is actual quantity, we can get an unfavorable variance of $0.03. Similarly, for coconut, we will see that there is no difference in the prices, so there will be no variance. So we have a $0 here. A difference in the rates of ice need also to be calculated, and taking a difference, multiplying it with the actual quantity of 190 grams, it gives us $0.23. Taking a total of all of them together gives us a total variance of $1.76. This is how the price variance will be calculated. Similarly, for quantity variance, we have to individually calculate the actual quantity minus standard quantity times standard price and add them all together. In example that I'm taking, I'm assuming that the actual production is the same as budgeted production. So standard quantity need not to be multiplied with actual production. We can take per unit actual quantity, per unit standard quantity for this example. So here we have a per unit actual quantity for pineapple juice is 100 milliliters, standard is 90 milliliters, standard rate is 0.05 per milliliter. Take a difference of that, multiplying with the standard price, it gives us an unfavorable variance of $0.5. For pineapple slice, similarly, standard quantity will be matched against the actual quantity and it will be multiplied with the standard rates. It will give us a favorable variance of 0.54. Similarly, for the coconut, we will calculate by taking actual quantity of 25 milliliters matched against the standard quantity of 30 milliliters and multiplying it with standard price. It gives us a favorable variance of $0.5. For the ice, we will similarly take the difference between the quantities 190 minus 150 and multiplying it with the standard rate of 0.0067. It gives us a total difference of 0.268. By taking a total of everything, it becomes a favorable variance of 0.27. In the quantity variance, we can further see that there is one difference within the mix of the ingredients. The standard mix is different than the actual. And another difference is in the total output that we are pouring out and giving 337 milliliters of pina colada rather than 300 milliliters of pina colada. This is further analyzed through a mix variance or a yield variance. The difference which has been caused by the change in the mix, that we are using more ice, less juice, or less coconut cream and a less slice of pineapple. This mix is changed now, and there will be one difference because of that. And for this, the formula that we are using is to match the actual mix against the standard mix. We will use weighted average of the mixes, weighted according to the standard prices, and then multiply it with the actual quantity. For yield variance, the difference between 300 milliliters of pina colada against the 337 milliliters of pina colada juice actually being given, that is the difference that we will match against each other, actual quantity minus the standard quantity, and multiplying it with the standard mix average rate. This weighted average standard price for actual mix and standard price for standard mix can be calculated by taking, from the same example, I need standard prices actual mix. So I'm taking standard rates and the actual quantities of individual, and standard prices will be multiplied with actual mix. Multiply them, take a total, add them, and when you divide the two amounts, it will give you an average rate. Similarly, for weighted average standard price for standard mix, we need standard prices and the standard quantity of mix. Multiply them together, add them, and then divide. It will give you a weighted average standard price for standard mix. Now, since you have these average rates, put them in the formula and you will calculate a mix variance and a yield variance. The addition of mix and yield variance will give us a total quantity variance.